Students, let's start with the next topic. Till now, we have studied how to find the square root by long division method. Now, next type is, let us discuss question number 3 from exercise 3.5. Question is, find the greatest 5-digit number which is a perfect square. Now, greatest 5-digit number is 99,999. Now we will be finding the greatest 5-digit number which is a perfect square. Let us try to solve this using long division method. As per rule, from the right hand side, we'll start pairing the digits here. Now when I start dividing, I found 9. This will be divisible by 3 because 9 is a perfect square. So according to the rule, this number will be multiplied by 2. That means I will be writing 6 here. And 99 will be taken here altogether. Now when I find it, if I'll try to multiply 61 by 1, it will be 61. It will be 124. Obviously 124 is greater. I will be writing 1 here. That means 61 will be written here. Now when I subtract, I found 3, 8 and 99 again will be taken all together. Here in the divisor, I'll be multiplying this number by 2. 6 will be written as it is. Multiplied by 2, I'll keep a dash here. Now, number is ending up with 9. Although it may or may not be a perfect square. So we will find the number which is nearest to this number. When I found it, I get this number becomes 6537. Okay, this number is a bit smaller than 3899. Let me write 6 here. Now, when I have written 6, the remainder is coming out to be 143. Now, this is the remainder. This cannot be divisible further as I don't have any number for the left here. That means 99,999 must be subtracted by 143 so that I can have a perfect square. Let's try this number, whether this 5-digit number, greatest 5-digit number will be a perfect square or not. I try to find the square root of this number using long division method again. This will be divisible by 3. Now 98 will be taken down. This number is multiplied by 2. It will come 6. Then again 1 here. 61. 3756 is there. Again using the same rule. This number is multiplied by 2. 6 will come as it is. If I'll try to multiply by 6, this number is completely divisible. That means square root of 99,856 is coming out to be 316. That means the greatest 5-digit number which is a perfect square is 99,856. Now let us discuss one more question here. Question number 4. Find the least number of a 4 digits which is a perfect square. Now least 4-digit number is 1000. 1, 2, 3, 4. This is the least number. Again, we will be using long division method to check which is the least number here. Now I'll start pairing the digits here from the right hand side. The smallest nearest perfect square which is less than 10 is 9. That means 3 3s are. The remainder is coming out to be 100 because both the zeros will be taken all together. This number is multiplied by 2. I'll get 6 here. Now I need to find the least 4-digit number. If according to the previous question, I'll find the number, let's say this is 61. That means I will get the remainder. In this case, I will be getting the number which will be subtracted. And if I'll subtract the given number from 1000, I will get a 3-digit number, which is not possible here. So what we'll do, I'll take the number immediate greater than 1, that is 2. it comes out to be 124. So what I will do, I'll write 2 here, and no doubt the number is immediate greater than the previous number. I get minus 24. Now this minus 24, although we've subtracted, it is negative, but the result which I've got is 24. The digit number is 24. So 1000 is added to 24, that means 1024, so that I can have a perfect square. This number 24 is the least number which is added to 1000, so that I can have a perfect square. Let's try to find out the perfect square here. I'll start pairing the digits. The perfect square which is smaller to 10, that is 9. It will be 124. 24 will be taken all together. Number will be multiplied by 2. 6 here. Here 2. 124. Therefore, 1024 is the least 4-digit number which is a perfect square. Now we have few questions here. Question number 5. Exercise 3.5. Find the least number which must be subtracted from each of the following to make them a perfect square. Let's try these parts here. I need to find the least number to be subtracted. Okay. First part is 5045. 5045, I have to do the same way. We are using long division method here. Okay. Here 50 is there. I need to find the perfect square which is less than 50 or equal to 50. That is 7 sevens are. It is 49. Remainder 1. 45 will be taken all together. 7 is to be multiplied by 2. It becomes 14. Now obviously, if I write 1 here, that is 141 into 1. You'll get 141 here. Now the remainder is 4. I cannot divide it further. Therefore, 4 is the least number to be subtracted so that I can have a perfect square. That means 5045 minus 4 will give 5041. Let's check this, whether this number is a perfect square or not. Using same method, this number will be divided by 7, 141 again by 2, so 1. That means 5041 is a perfect square. We'll take one more example here. Now the question is 194491 will be a perfect square, or we need to find the least number which must be subtracted from this number so that I can have a perfect square. Now the least number or the smaller number, smaller perfect square which is less than 19 is 16. 16 is 4 fours are. 16 will come here. Okay, remainder 3. 44 will be taken all together. This number is multiplied by 2 again. It will come out to be 8. Now when I start multiplying and checking, I'll find this number comes out to be 336, which is of course less than 344. I'll write 4 here. Now 336. When I subtract, I found this comes out to be 14. That is 8, and 91 will be taken together. This number is to be multiplied by 2. That is 8. This 8 will be written as it is. Now I'll put a dash here. Now I need to find the number. If I multiply by 2, obviously the number will be greater than 891. It will be 1 only. That is 881. So 10. Hence we can say here 10 is the least number which is to be subtracted from the given number so that I can have perfect square root, perfect square number. You can check by solving it. Next type, this is question number 6. Find the least number which must be added to the following number to make them a perfect square. Now previously we have discussed the least number to be subtracted, and now we will be discussing least number to be added. I am taking example of first part, 3720. Using the same concept, pairing the digits from the right hand side and then start solving. When I find this number is nearest to 6, that is 36,120. This number is multiplied by 2. Okay, now 120 is there. Obviously, this number, if I put 1, if I'll write 1 here, this will be 121. Students, please remember, we are finding the least number to be added. And in this case, what we'll be doing, we will be finding the immediate number which is greater than 120. In subtraction, we are finding the least number which is nearest to the given number. And in case of adding the least number, we need to find the number which is immediately greater than this. Obviously, if I'll write 0, this won't be possible. I'll write 1, because writing 1, the number will be immediate greater than 120. I'll write 1 here. That is 121. Difference is minus 1. That means 3720. I must add 1 to it so that I can have a perfect square number. 3721. Let's check whether this number is a perfect square or not. 3721. Starting from right hand side, I'll start pairing the digits. Number will be divisible by 6. 36, 121. Number will be multiplied by 2. It will come out to be 12 with 1 here. So 121. So automatically we found the number, the least number which is added to 3720, so that I can have a perfect square. One more type is there. One more example rather. This is exercise 3.5, sixth question, third part. Okay, 4931. Let's try this. Now here, this will be 7 sevens are 49. 7 will be multiplied by 2, it will become 14 here. And the number is 31. Here if you'll see, 31 is less than, because even if I'll put 1 here, that means this number will definitely be less than 31. But that's right, we need to find immediate number which is greater than 1 here, the given number here. I'll try with 1, because if I write 0, the whole number will become 0 and I won't be able to divide. That's why I need to take 1 here. If I write 1, it will be 141. Difference will be, you can subtract 31 like this, it will be 110. Because we are subtracting bigger from smaller number, so it will be negative 110. That means 4931. I must be adding 110 to it so that I can have a perfect square. So this number will be 5041. And let's check it further. 5041. 7 sevens are 49 here. 141. 14 and again 1. So it is coming out to be a perfect square. So here we have discussed the least number which are to be added and subtracted in the given number so that we can have a perfect square. Students, please remember, whenever we are to find the smallest number which are to be multiplied and divided, we will always be using prime factorization. We will be finding prime factors in case the least number to be multiplied or divided. But in cases where we need to find the least number to be added or subtracted, we will always be using long division method so that we can find the perfect square root. Thank you, students.